All right, here are your solutions to the review. Triangle ABC. So we're going to draw a triangle ABC and label it. A to B is 7, B to C is 9, and A to C is 12. So the first thing I recognize is this is a side triangle, which means we're going to use the law of cosines. And all I want to do is find angle C. So we're going to start with inverse cosine. Now, the angle opposite of C is what we start with. So we're going to start with 7, and then that's the only time we're going to use 7. So now the order doesn't matter. We're going to use 12, we're going to use 9, negative 2 is part of the formula, and then again 12 and 9, and then we're going to type that in and get our answer. So we need to open up Desmos, and I'm going to show it too, so you can press pause if you like. So here for Desmos, make sure it's in degrees. So make sure degrees is highlighted. And then we're going to go inverse cosine. Oh, let's try that again. What did I do here? Let's try it again. All right. There it is. Inverse cosine, divide sign, and then start typing. So 7 squared, subtract 12 squared, subtract 9 squared, and then it's negative 2 times 12 times 9. So that's about 35 degrees. So 35, I'm going to say 35.4. All right, try the second one first and then press play. So triangle DEF, where angle D is 30, angle E is 80, D to E is 9. So already I know this is an angle side angle, which means it's law of sines. I need to find this angle here that's opposite of 9 first. So to find that angle, I'm going to go 180, take away 30, take away 80, and get that answer first. So that angle here is 70. So then we're going to go sine 70 over 9, and then what I'm looking for is D to F. So I'm going to put an X there. So the angle opposite of that is 80. So I know it's going to be a little bigger than 9. And then I solve it. So 9 times sine 80 divided by sine 70. Again, I'm going to take Desmos and type it in. So 9 sine 80 divided by sine 70. And that's 9.4. All right, try this one. This one's a little trickier one. Try and always try it first. So XYZ, we're going to label it. So angle Y is 30, X to Z is 12, Y to Z is 10. So this is a side angle. That's the ambiguous case for law of sines. So I know an angle and its opposite side. So I know sine 30 over 12. The only other angle I can find right now is opposite of 10. So the only angle I can find is X. And that's what I'm looking for anyways. So that's good. And that's over 10. So to get X by itself, it's going to be the inverse whenever you're looking for a missing angle. And you're going to go 10 times sine 30 divided by 12. That's how you get X by itself. Let's type that in. Now, there are two possible answers we have to look at. So one answer could be 24.6. But then I'm going to take and subtract 180 from it. So I'm going to go 180 take away 24.6. And the other angle I'm looking at is 155.4. So there could be an acute angle or they could be an obtuse angle. How do I know? So first of all, I definitely know this works. The acute will work if there's one there, but this one may or may not work. So the other angle that's inside the triangle is 30. So if I go 30 plus 155.4, that answer has to be less than 180, or else it won't make a triangle. And if you add this up, it's bigger than 180. So that angle doesn't work, and so the only angle that works is 24.6. And there's your answer. All right, next, find the area here of this triangle. So let's recognize what we have. So FGH, angle F is 27, angle H is 88, and then G to H is 11. All right, so I need side angle side. So if I have this side, then I have side angle side. So I need to solve for a missing side first. So again, this is a angle side triangle. That means it's law of sines. I need to find the angle opposite of x. So in other words, I need to go 180 take away 27 take away 88. So my brain doesn't want to do that. So let's just use Desmos for our brain to do it. So again, we're going to go 180 take away 27 take away 88. That's 65. All right, so we have sine 27 over 11. We have sine 65 over x. And now we're going to solve for x. This is not finding the area yet. So we're going to go 11 times sine 65 divided by sine 27. But we need that number. So let's use Desmos again and see what that answer is. So 11 sine 65 divided by sine 27. So about 22? Or 21 point, yeah, 22. Now, we can find the area. So because we have side angle side, that side we just found, which was 22, the other side, which is 11, and then the angle in between them, sine of 88, that's what we're going to type in to find the area. So once we have it, we only need this part here is side angle side. So we're going to go 11 times, let's try it again. We're going to go 1/2. Then we're going to go times 22 times 11, and then sine of 88. So 120.9. All right, let's do a story. Two ships leave the same port at the same time. The first ship travels 200 miles. The second one 180. The angle the ships make with the port is 20. So we have one that's 180. We have another one that is 200. And the angle they make with the port is 20. And the question is, how far apart are the ships at this time? So you see we have side angle side. So to find the area, we have all the things we need. We multiply 1/2 times one side times the other side, and then sine of the angle in between them, and then that will give you the answer. So again, I'm going to go 1/2 times 180 times 200 times the sine of 20. Something went wrong. What went wrong? What did I type in wrong? 1/2. The answer is not that. Is it this? I know what I did. It's in degrees, and it is degrees. Oh, it's the area. I was thinking the missing side. So this question is not about area. So what am I doing now? So it didn't make any sense about how far away are the ships from each other. And here I do area. I'm being really not accurate. So I scratched it out. You know why? Because I looked at the answer. 6,000 something? That did not make sense. So I recognize it's not an area question. I just did area, but it's not area. Side angle side. It is the law of cosine. So big square root sign. Start with a side and square it, plus another side and square it. Subtract 2. Same sides, 180, 200, and then cosine of the angle in between them. That's it to find a missing side. So let's do that here. Let's do it right. I go SQRT, and then let's start typing. So 180 squared plus 200 squared. Subtract 2 times 180 times 200, and then cosine of the angle in between them. That's much better. So that answer is 68.9, and then we'd say the ships are 68.9 miles from each other at this time. Let's make sure we do this one right. Here's another story. To measure the height of a building, Teresa measures the angle of elevation to the top of the building. So here we have a building. Here's Teresa. So to measure the top of that building, that's 48 degrees. She then walks closer to the building, and now the angle to the top is 58. And it says, how tall is this building? So, how do I do that? So I want you to see there's a triangle on the left, and there's a triangle on the right. And there's one side that is shared by both triangles. I want that side. That's going to help me find the height. So I'm going to start with the triangle on the left. I'm going to use some basic geometry. So I'm going to find this angle beside 58. So I'm going to go 180, take away 58. And then I'm going to get 122. Then I'm going to go 180, take away 122, take away 48, and that's going to give me the answer 10. That's the angle up here. Now, that angle is important because it's opposite of the only side I know. So now I'm going to write sine 10 over 30, and then to find x, the angle opposite of x is 48, so sine 48 over x, and then I'm going to solve it. So I'm going to go 30 times sine 48 divided by sine 10. That's step one. So I'm going to take my calculator, 30 sine 48 divided by sine 10. So that missing side there is 128.3 or 0.4. Next, I'm now going to look at the triangle on the right to find the height. This is just a right triangle. So katsoa. So this angle 58, h is opposite, and x, which I know now, is the hypotenuse. So opposite over hypotenuse is sine. So we're going to go sine 58 equals 1 ratio, and it's h, which is opposite, over x, which we said is 128.4. Then to get h by itself, we multiply and then use our calculator. So it's 128.4 sine 58. That's 108.8 or 108.9. So the height of the building is we say it's 108.9 feet. Tall building. Turn the page. Another story. An airplane leaves LAX airport to fly to Dallas, a distance of 1,200 miles. After flying a distance of 300 miles, the pilot notices an error in direction. The airplane is 13 degrees off course. At this time, how far is the airplane from Dallas? So we're going to triangulate this. So we have LA to Dallas. We said that's a distance of 1,200 miles. But instead of going directly there, the plane went off course 13 degrees. And at 300 miles, it was finally noticed. And the question is, at that time, how far is the airplane, which is right there, from Dallas? So that's right there. How far away is it? So I'm going to answer that one underneath here. So that's side, angle, side, law of cosine. So we're going to go 300 squared plus 1200 squared minus 2, and then 300, 1200, and then cosine of 13. So we'll start there. That will tell you how far away the plane is from Dallas at that time. Let's do that with Desmos. So we're going to start with the square root and then type it in. So 300 squared plus 1200 squared. Oops. What happened here? Subtract 2, and then times 300 times 1200, and then cosine 13. So at that time, it's about 910 miles away. Then the question is, at what angle must the pilot turn to bring the airplane to correct the direction of the airplane towards Dallas? So we want to put it back on course. So we need to find this angle here on the outside. Now, to find that angle on the outside, this is the direction the plane would turn. We're actually going to find the angle on the inside and then subtract 180. So now we know all three sides. Again, it's law of cosines. So we're going to find the angle on the inside first. So we're going to start with 1200, and then we'll use 300 and 910, and then negative 2, 300 and 910, and then find that angle to begin with. So again, I'm going to type this into Desmos. So inverse cosine, do that again. And then 1200 squared, subtract 300 squared, subtract 910 squared, negative 2 times 300 times 910. All right. So that's 162.9. Now that's not the angle the plane is going to turn. So it's the angle on the outside is what they'll turn, that angle there. So we're going to go 180 subtract 162.9, and you get 17.1. That's the angle the plane is going to turn. So the plane is 910 miles away from Dallas and has to turn at an angle of 17.1 degrees to head back to Dallas properly. Next one. A triangular lot is side, 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 and you have a bag of grass that covers 650 feet squared. What is the area of this lot? So side, side, side is Heron's law. There are two parts to it. So first we're going to add all the sides, 200, 150, and 90. Add them all up and divide by 2. There's step 1. So we'll take Desmos and add them up. In fact, I'm going to do a divide sign already. So it's 200 plus 150 plus 190. Divided by 2. That's 270. Now the second part of the formula, I'm going to write it down too, but it's a big square root. We start with 270, and then we go 270, and you take away each side one at a time. So 270 take away 200, 270 take away 150, 270 take away 90, and then type it in. So it's a big square root sign, and we start with 270, and then we start subtracting. So 270 take away 200, 270 take away 150, and then 270 take away 90. All right, and you get the answer 20,205 feet squared. Then, to see how many bags of grass you need to buy, because one bag covers 650, we're going to take 20,205, and we're going to divide by 650. And that means we need more than what we see. So So 31 bags won't be enough because it's more than 31. So you'll need 32 bags. Another story. Two cars leave a parking lot at the same time. The first car is traveling at a speed of 57 miles per hour and heading north 20 degrees east. The second car is traveling 48 miles an hour and is going south 30 degrees east. And then the question is, how far apart are the cars? So let's break it down. The first car is going 57 miles an hour, and then times 3 is how many miles have you gone in that. So you can use Desmos or not, but that's 150 and 20, and that's 171. And the other one's traveling 48 miles an hour for 3. That's 144 when you multiply that together. And then what kind of triangle do we have? Well, I need to find that angle inside the triangle. So I need to go 180, take away 20, take away 30 to know what that angle is inside. So that angle inside is 130. Now I have side angle side. So to know how far apart the cars are, it's a big straight, it's laws of cosines. We start with 171 or 144 and use the formula. And then cosine of the angle, which is 130. And we're going to type that into Desmos. And cosine 130. And so that's 285.7 miles apart. All right, last story, then some graphs. The cruise ship leaves port, headed to an island that is 200 miles away. So here's the port, and here is the island. That is 200 miles. After 30 minutes, the ship turns at an angle of 45 degrees and travels for an hour in the new direction to avoid a storm. At this time, how far away is the cruise ship? So, the cruise ship speed is a constant 50 miles an hour. So after 30 minutes, let's say it's there, how far have you gone? 50 miles an hour. That means you divide by 2. In 30 minutes, you would have gone 25 miles. And then you're turning at an angle of 45 degrees. And you travel for another, how long? For an hour in the new direction. So 1 hour in the new direction is 50 miles. And then how far apart at that time, how far away are you from the island? So if I go 200, subtract 25, this side is 175, and I have side angle side. So that's the law of cosines. So that's 175 squared plus 50 squared, minus 2 175, 50, and then cosine of 45. All right, so we're going to type that in. Here we go. Type it in, minus 2 times 175 times 50, and then the cosine of 45. So that's 144. So at that time, the boat is 144 miles away from the island. All right, turn the page. All right, see if we can do some graphing. So I want to graph this. Notice the number in front multiplying is the amplitude. It's always a positive number. And then the period, we start with 2 pi and do the inverse. So that's pi over 2. And then we're going to draw a set of axes. Because we control our own scale, it's much easier. We're going to count to 4. 1, 2, 3, 4, pi over 2. 1, 2, 3, 4, that's just pi. 1, 2, 3, 4. 1, 2, 3, 4. And again, it goes up to 1 and down to -1. And then we're going to draw the graph. So cosine usually starts at the top. But because it's negative, there's a reflection, it's going to start at the bottom. At pi over 2, it's going to be at the bottom. That's the end of one cycle. And then in the middle, it'll be at the top. And then we fill in the middle points of the wave. And then we have our pattern that we're going to repeat over and over again. And once you have the pattern, you then can connect. Feel free to pause. All right, second graph. Amplitude again is 2. To find the period, we do the inverse of what I see. So that's actually negative pi over 2. And then we do, instead of 1/2, you would divide by half. It's times 2, the inverse and inverse. And then when you simplify it, that answer is negative pi. That's where the graph starts. Oops, that's the phase shift. Let's rewrite that. This is the period. We'll do that. 2 pi. That's just half x. What's the inverse of 1/2 x? Times 2. So that's 4 pi. So the period is 4 pi. It starts at negative pi. And the amplitude is 2. All right, let's draw a graph. Again, we're going to count to 4. 1, 2, 3, 4. That's 4 pi. 1, 2, 3, 4, 8 pi. 1, 2, 3, 4. All right, so there's my scale on the x. 2 and -2. All right, so first thing we do is find where negative pi is. So if this is negative 4 pi with this scale, it goes -3, -2. -1 is actually right here. And sine starts in the middle at negative pi. So I find where -1 pi is, and sine starts in the middle. From there, I follow my pattern. So from there, it goes to the top, back to the middle, to the bottom, to the middle, and we follow our pattern from there. And we have our graph. I press pause, and again, try your best. Go back and look at it again if it didn't work. I want to graph this equation. The amplitude is +1. The period, I'll do it right this time, is 2 pi, and we divide by 2, which is pi. The phase shift is positive pi over 2, and again, I divide by 2, which is pi over 4. And then the vertical shift is -1. So the first thing I'm going to do is I'm going to draw a set of axes again. Now I'm going to use a different color here and draw a midline in. So what's a good color for me to have? I'm going to do purple. So I'm going to do this at -1. So I'm going to draw where -1 is. This right here. This is my new midline. for my wave. So everything's going to come from the purple line when I count for the amplitude. Now, I'm also going to do the scale. So it's pi for the period. So I'm going to go 1, 2, 3, pi. And then do it again for, that's 2 pi. To the left, that's negative pi. To the left, that's negative 2 pi. And then we can figure this out. So it's going to start at, pi over 4. So that means 1 to the right. Right here is pi over 4 with this scale. And we go to the midline. Now cosine starts usually at the top of the wave. So from the midline we'd count up 1. But because it's negative, from this midline we count down 1. So there's the bottom of my wave. And then I follow the pattern from there. So it goes, that's the bottom, middle, top, middle, bottom, middle, top, middle, bottom. And do the same thing on this side. All from the purple line, that new midline, and then draw the wave that then goes across. And you can see it's been shifted down 1 and shifted to the left. That has all the parts to it. Again, if you need to do it again with graph paper, try it again from the beginning and see if you can do it without me. And then press play again. All right, a few more graphs. Can we graph this one? The amplitude is positive 1. The period is 2 pi times 4. That's 8 pi. I'm going to draw a set of axes. And again, because it's 8 pi, I'm going to go 1, 2, 3, 4. That's 8. 1, 2, 3, 4. That's 16. Just double it. 2, 3. That's negative 8 and negative 16. There's no phase shift, so it starts right on the axes, and negative cosine starts at the bottom. So on the axes, we start at the bottom. At 8 pi, we'll be at the bottom. And we can follow the pattern. Middle, top, middle, bottom, middle, top, middle, bottom. And then keep that pattern going. And then connect the points and you have your wave. Anytime you need to look at a question a second time, just rewind and look at it a second time. All right, 2 more graphs. The amplitude here is 2. The period is 2 pi divided by 2, which is pi. And the phase shift is positive pi over 2 divided by 2, which is pi over 4. We're going to draw our set of axes. This goes to 2 and down to negative 2. I'm going to go 1, 2, 3, 4 is going to be pi. 2, 3, 4, double it, 2 pi. Same thing to the left. And then I'm going to draw it. So we're going to start at negative pi over 4. Or sorry, that should say positive pi over 4, which is right here, positive pi over 4. And sine starts in the middle. That's where the graph starts. And then we're going to go, because it's positive, it goes to the top, middle, bottom, middle, top, middle, bottom. And then we're going to follow that pattern until I don't want to follow that pattern anymore. And then connect. All right, one more left. Again, you can rewind and try it again if you need to practice. All right, the amplitude is positive 2. The period is 2 pi. And there's nothing that would change it. There's nothing dividing or multiplying, so it's just 2 pi. The phase shift is negative pi over 2. And again, there's nothing to divide, so it's just negative pi over 2. And the vertical shift is 1. So I'm going to take my purple marker again, and I'm going to draw 1. Y equals 1. Well, first I'm going to draw a set of axes, and then we'll do that. So let me draw a set of axes first. Then, with that set of axes, I'm going to draw 1. And that's my new midline. I'm going to go back to my graph. I'm going to go 1, 2, 3, 4 is going to be 2 pi, and 1, 2, 3, 4 is 4 pi. And follow that to the left and right. So with an amplitude of 2, I got to make sure I at least get up to 3. And negative 3, won't go down that low, and then go from there. So, here we go. So we start here at the phase shift. So where is negative pi over 2 on this? So that's right here is negative pi over 2. We go to the midline, and sine starts right there on the midline. And then because it's negative, the pattern is it goes down 2 from the purple line, and then back to the middle, and then up 2, back to the purple, down 2, back to the middle, up, back to the middle. And then we're going to follow that pattern. And then connect. And that's it. So, if you need to practice again on another piece of paper, write it down and try it a second time or a third time. Watch the video until you feel like you feel good about it, okay? All right, Mr. G Math over and out. Good luck on your exam.